Hello everyone, welcome back to Linked Frequency. In this tutorial, we are going to learn about how to interface MAX30100 heart rate monitoring sensor with Arduino Nano development board. This is the 10th tutorial of practice project for PCB designers. This one is going to be a little complicated so that you can understand how to interface the off-the-shelf module, which are so-called DIY modules in the market, with the development boards like Arduino Nano. I am Vaibhav Sugandhi, passionate PCB designer and technology startup founder. Let's start with the design of this particular project with the black box analysis. Here we have a black box analysis for our project. This is so-called a project. Why? Because we are not designing any module further. We are developing one kit or maybe a project which includes more than one or more than two modules integrated together. First thing is we are using a lithium-ion battery pack so that this entire project will be portable. Thereafter, we will be using a battery monitoring circuit so that we can monitor how much charge left in this particular battery and indicate how much time it will work for this particular project. Then we will be using a DC power supply or DC to DC converter, which will convert the high voltage of a lithium-ion battery pack into a required voltage for the entire electronic circuit that we are connecting. Thereafter, we will be having a one main controlling unit, which is also called MCU in shortcut, which will be controlling the entire peripherals as per the requirement, or all the algorithms or program has to be done on this particular level. We will be having a USB programming circuit inside this main controller development board so that we need not to bring up any circuit which will convert the USB data into a microcontroller programmable data. Thereafter, we have a MAX30100 module, which is a heart rate sensor module, which includes SpO2 data sensing as well. So this module is being interfaced with the main controlling unit, and then the data will be displayed on the OLED display. This OLED display module is available in variety of sizes and interfacing level in market. However, we are using a I2C based 0.96 inch OLED module, just easy for our development activity. We will be having a one user interface device which will help the user to select what function to be activated and at what rate to be activated. If we are using this entire project for continuous heart rate monitoring, then we need to have one user interface where we can set the timing or set certain levels so that it will indicate something for the user. That's why we will be having a user interface device. What are those user interface device, or what are the things to be added in the user interface device? We'll get to know in the white box analysis. This is how the black box analysis for the project looks like. And this is very simple, very easy for the beginners to start with. However, it is not a single PCB that we are developing. It is an integration of multiple modules available in the market. Now, if you go for the white box analysis, you can see here in the case of lithium-ion battery pack, we are selecting a 8.4 volt 2 series lithium-ion battery pack. Why? Because we want to have a greater voltage than the minimum voltage required for the Arduino Nano development board or the MAX30100 module. Then only the entire circuit works. That's why we are having the 8.4 volt combination in the lithium-ion battery pack so that we can convert it further into a 5 volt by using a LM35 or LM7805 switching voltage regulator. This is a DC power supply which converts the 8.4 volt into a 5 volt, and then we have a voltage monitoring sensor here, which is again a voltage divider network most of the time, and here also a voltage divider network which will monitor how much voltage left in this particular lithium-ion battery pack. And at the main controlling unit, we will be having a Arduino Nano development board, which is Arduino Nano V3 in common sense called in market. And we will be having a micro USB cable along with that so that we can program the Arduino Nano development board as per our requirement. And MAX30100 module is connected with Arduino Nano development board via I2C bus so that we can access or we can control this MAX30100 module, which measures the heart rate and SpO2 of a human body. Then we will be having a OLED display which is again connected to the same I2C bus with a different address, but it is connected to the same microcontroller or the Arduino Nano development board. Via programming, we can display the heart rate and SpO2 measured on this MAX30100 module. Thereafter, for the user interface purpose, we are using a rotary encoder which comes with a two important feature. One is a rotating feature in clockwise and anti-clockwise direction. Along with that, it will be having the embedded switch for click option. It's a kind of a tactile switch Whenever a user presses on that, you can create a menu on the OLED so that they can select a variety of functions and operate with that. This is how our entire white box analysis looks like. And again, here also we have not done the morphological chart and datasheet analysis. I believe you're doing it off the record on this particular video. Why? Because it will be too long if I continue with the datasheet analysis and morphological chart for each and every project. Now let's jump into the next part of the design activity, which is all about our schematic design using the EasyEDA. Just before that, I have some design reference website for you to understand how exactly our design activity works. See, first website that I recommend for you to understand the MAX30100 sensor working principle, behavior, and scientific reason behind how it exactly works, you can refer this particular website. Again, this particular tutorial is not referred or sponsored by any of these websites or the owner or the proprietary of these, but I am very happy to see that these websites are having a very good content. That's why I am recommending them from my side. Lastminuteengineers.com is the great website to learn anything for the beginners. Second one is howtoelectronics.com. This one is also having a great tutorial regarding how to interface MAX30100 sensor with Arduino Nano development board. And lastly, the most important and a very genuine site is Arduino.cc, which is official site for Arduino development boards and the entire company of Arduino. There also you can learn a lot of things with respect to MAX30100 sensor. Alongside, you can refer the MAX30100 datasheet for the detailed information. The datasheet, whatever it provides, it is more than enough for any website that you are referring. If you are not interested to refer the basic level information on these websites, then obviously the detailed information, a technical and true authenticated information is available in the datasheet of any IC, such that the MAX30100. Having said that, let's jump on the EasyEDA tool and start designing our circuit. First thing is, I am on the EasyEDA, log in your account and start with the design activity. First, I will go to the file, click on the new and create a new project. MAX30100 with Arduino. I'll click on the save and now I will start designing the circuit as we do with a fast forward way. Alright, now you can see that this is how the schematic of our first project, which is all about interfacing MAX30100 module with Arduino Nano development board looks like. Here we have added one small diode for a protection with the battery. This is a RMC connector for the battery itself. We are connecting a battery here directly. A two series connected battery pack will be connected here, and this diode protects the entire electronic circuit from the reverse connection of the battery. By mistake, if we connect a reverse, of course it is not possible. Why? Because we are using a RMC connector for that matter only. However, if you use a normal Berg header or a normal soldering and all, there is a possibility that you connect a positive to the negative, negative to the positive. In our case, this diode will protect in such kind of a situation. And after that, we have a 7805 which will convert the 8.4 volt or a 7.6 volt coming from the battery into a 5 volt DC. And then we have a OLED module here and MAX30100 module here. Directly we are using a module, and then we have a user interface rotary encoder module here. This is the voltage divider circuit which we discussed in our previous tutorial, and one of the wonderful circuit that I use in most of our project. In industry also, people use it for more often in every project wherever there is a battery is included. And then we have our main controlling unit that is all about Arduino Nano development board. You can notice whenever I am not using any of the GPIO, we are going to use this no connection flag. This no connection flag to be added on the pin where it is not used. When we are not using any one of the pin for any microcontroller or maybe a component or a development board or anything, you just make sure that you add a no connection flag. That will indicate the software that I'm not using that particular pin purposefully. I have not left it unintentionally or unknowingly. That is what the indication for the software. Now we need to change the footprint for this particular component because RMC connector has to be updated with a footprint. This is a normal Berg header or normal header connection ka footprint. So now I'll change it to RMC 2-pin connector. I think we have designed our own footprint a long back ago, and I'm going to use the same thing. You can see here we have a 8-pin, 3-pin, 5-pin, 6-pin, and our another company UTD designers, we have a 2-pin. So I'll select it and I'll update it. You can look at this. This notch will indicate the side of the one side of the entire connector. So by mistake also, there is no possibility that a person can insert it in the other way. It is one-way insert connector, so just not possible to insert it in the other way. That is the first level of protection for the battery connection or reverse connection of the battery with the electronic circuit. But in worst case scenario, if even that happens, this diode will save our entire electronic. Just 1 rupee diode will save the entire electronic, which is costing more than 5,000 rupees. A beautiful electronics. Okay. So now let's jump into the PCB designing section. So I'll just convert it to a PCB layout, and here we have, and let's fast forward it to design it the way how we design it. All right, now you can see that the entire PCB project is ready now. So again, this one is a project because it is an integration of multiple modules, hence I call it as a project. And you can see that all these modules are placed in such a way that it looks like a project for a mini project, or maybe a whatever kind of a project you can call it as. I call it as a practice project for PCB designer, but for your college purpose or for your hobby project, whatever you want to call, you call it as. To arrange it in such a way that it looks like a project and make it very suitable for the PCB designing and IPC standard, we have placed all these components as per the requirement. Now you can see that we have a OLED here and all these components are here. With this kind of a configuration and with this kind of a circuit complexity, it is not possible to complete the routing with a single layer copper. That's why we have utilized the top layer copper as well. No SMD component, all are through hole component, all are modules, but still we are using a 2 layer of copper while designing the track from one point to another point. Along with that, when I poured the copper for the ground layering or ground connection, I have poured it for the bottom copper as well as the top copper. Just I have created this small notch here so that whenever I want to select any specific copper layer, I just need to select it one by one. If I overlap it one on the other, then it is very difficult for us to select a specific one. While you are in the top layer also, you can select the bottom one. So that's why it is mandatory to make a small notch on the edge of the copper pouring. And other than that, you can see that routings are done with a 0.6 mm layer track width and 1 mm track width. For power and all, we have used 1 mm, and for most of the connections, we have used 1 mm because we have a sufficient space and a lot of clearance for one connection to another connection. For some connection where there is no possible to go with a 1 mm, there I have used a 0.6 mm. You can still increase it to 1 mm. There is no big deal. It is still possible, but that's okay. It's a personal choice. And thereafter, we can go to the 2D diagram. This is how the PCB looks like. Looks very wonderful to me. It's absolutely suitable to call it as a hobby project, or maybe a mini project, whatever you want to call for your academic year, or maybe a personal hobby project level. And then if you go to the 3D model, this is how it looks like. You can see the Arduino Nano USB cable is on the edge side or the border side so that you can program it at any point of time. And you can see the OLED here and user interface here. We have to manage this placement of the component in such a way that user should be able to place one finger of the left hand on this MAX sensor, and with the right hand he can use this rotary encoder to operate this screen as per the requirement. You have to think a user interface or user experience level while you are designing the components or while you are designing the PCB, which includes user interface. That's why this particular part is very essential to understand. And this is how the RMC connector looks like. Here 3D model is not loaded. We have not uploaded the 3D model, but you can see that it has a one-side connection, so it goes in only one direction. So this is how about we need to understand and we need to design about the MAX30100 sensor interfacing with the Arduino Nano development board. This is all about this particular project. I hope you learned something new in this tutorial, and I hope you enjoyed the entire tutorial. Thank you so much for watching this entire tutorial till here, and I'm very sure you are going to practice it by yourself. If you have any questions, any concerns, if you got stuck in anything, please feel free to ask any questions in the comment section. We will be answering you as soon as possible. Again, thank you so much for watching. See you again in the next video. Until then, tune yourself to make a difference.